Okay, that's good. So, how far did you guys get up to? D? D? Did anyone do E? Wait,
Write those down.
like, do you, okay. Let's see what we need to do here. Okay, so A. Who wants to tell me how to do A? Limit as x approaches 1, x minus 1 over x squared plus 1. What do you do here?
Just plug in 1.
Yeah.
Plug in. It's 1 minus 1 over 1 plus 1. So that's 0 over 2, which is 0. Yeah, so plug in. Step 1, plug in. It's the first thing you do, and it worked out here. So limit as x approaches 1 of x minus 1 over 1 minus x squared. What do we do?
Back to the bottom.
Yeah.
Right, no. So the first thing you should think is to plug in, but here you should realize can't plug in because division by 0. Right, Jhevon? Okay, so you don't do that. So the next step 2 in the process is, well, if I can't plug in, try to simplify so you can plug in. So the denominator factors into what?
When you pull out the negative sign, it would be x minus 1, x plus 1.
Pull out what negative sign?
Factor out a negative first.
Oh, so you want to think of this as x minus 1 over negative of x squared minus 1?
Yeah.
So we'd have x minus 1, x plus 1, the x minus 1s would cancel, and so we'd have the limit as x approaches 1 of minus 1 over x plus 1. And what is that?
Negative.
Negative half. Now you can plug in. All right. So step 2. C. Limit as x approaches 1, x plus 1 over x squared minus 1. Okay, so what do we do here?
Well, first see if you can plug in.
Right, so you see if you can plug in. Can't because you divide by 0. So next thing,
Simplify.
try to simplify. Does this simplify?
Yes.
Denominator is the same thing like here, so it's x minus 1 times x plus 1, and yes, we can cancel that. So we end up with, now what?
Graph it.
Huh?
Can't plug in 1 because
Well, you can't plug in 1, so what do you do now?
graph it.
Graph it?
Okay,
What does the
see.
graph look like?
There's a hole at x minus 1.
Yeah?
There's a vertical axis so that x equals 1.
Yeah? Alright, so at x equals 1, there's a vertical asymptote. What does it look like around it? Like that. Right? It's like the 1 over x graph, but shifted, right? Remember when you had y equals 1 over x? That was on quiz 1, I think. It looks like this. So it's like that, but it's shifted, because I subtracted 1 from the x. So that's what it would look like. And now that you know what the graph looks like, what's the answer? D and E. Does not exist, because on the right side it's shooting up to infinity, on the left side it's shooting down to negative infinity. So there is a disagreement. What if I had said a little plus sign here? what would the answer be?
Oh, wait,
If I put that,
Infinity.
it would be infinity. You just look at the right side. Right? Just checking that we know. Okay. Right, so, and again, you're going through the strategy. Step 1, you always try to plug in. Step 2, if you can't plug in, because you divide by 0, there's a negative under a radical or whatever, try to simplify to see if you can plug in afterwards. Step 3, well, I didn't tell you special techniques yet, so let's skip over that. Step 4 would be, well, if I can't, after I simplify, I still can't plug in, then we do like a graph or a table of values or something like that to try to figure out. So, some people might be tempted to, after they simplify and they realize it does work, to just immediately say D and E, but that will be incorrect. You need further assessment here. Because ultimately, the limit doesn't care whether you can plug in or not, really. So just because you can't plug in doesn't mean you can use that to judge the answer. You have to go a little bit further. D. Here. Draw the graph. What does the graph look like?
Like the V.
Ah, which graph? Well, that's a graph of what?
Oh, that's absolute value. Okay, yeah.
Right, this is y equals absolute value of x, right?
Yeah, so would it,
Here I'm dividing that by x.
oh, I don't know.
What would the picture look like?
Is it just X? The line of X?
Maybe I should ask a different question. What does the absolute value of x mean? What's the definition of absolute value of x?
Positive X.
Well, what does that mean to be positive? Like, how would you write that down in a formula? I think most people would intuitively know, okay, absolute value, oh, I know it's always positive or whatever. But what does that, how do you write that down? Like, what does that mean mathematically? How do you define it? Yeah?
Isn't it like the number of, like the number away from 0?
The distance away from 0? That's true, but does that help you solve this? So you should know what absolute value is as a formula. It's actually a piecewise function. What it does is it just gives you x if your x is positive. So like if you have the absolute value of 3, it just gives you back 3. It gives you back exactly what's inside the absolute values if it's already positive. It gives you negative x if your x is negative. Right? So if inside the absolute value you have a negative number, what it does is it takes the negative of the negative number to turn it positive. That's how it makes it positive. And it's 0 when x is 0. Right? So the absolute value of 0 is 0. This is the definition that's important. You need to know that. Right? So knowing that it's the distance from 0 or that it just always returns a positive or 0 result is fine, but it doesn't really help you computationally speaking to simplify anything. Right? You can't really use those definitions really. But this you could use, and in fact, that tells us that we can actually split this limit up into several cases. So in the first situation, the limit that we're looking at is x over x, and this is in the situation where our x is positive. In the situation where the x is negative, it gives us minus x over x. And in the situation where x is 0, it gives us gibberish. Because you can't divide by 0, it's meaningless. So we really have two things to contend with here, and notice that this you can actually simplify. You can actually apply step 2. That simplifies to 1 if x is positive. It simplifies to negative 1 if x is negative. Technically, you could put one-sided limits here if you want. You put a little plus sign here and a minus sign here, but you'll essentially get the same thing. By the way, this will tell you what the graph actually looks like. The graph actually looks like it's 1, so it's just a horizontal line, 1 on the right side, and it's a horizontal line at -1 on the left side. And there are holes along the, where x equals 0. So it's like, this part gets divided by x, so it just becomes horizontal. This part gets divided by x, but it's a negative number, so it flips underneath the bottom and is horizontal. Now, knowing that that's the definition and this is the graph, what would you say the answer is? Does not exist. D and E. It's two different things. Like from the right side it's 1, from the left side it's negative. That one does not exist. Where are we? E. What do we do here? Yeah?
You want to get rid of the square root, so you multiply the top and the bottom by square root of 1 plus 3x plus 1.
So that is called rationalizing. And you multiply the top and the bottom by what's this one called? What's it called here? What's the name of that thing, you remember? It's called a conjugate. So this is the conjugate of the radical 1 plus 3x minus 1. Okay. So you want to rationalize here because you can't plug in, so we want to simplify. Well, how do you simplify that? Well, multiply divide by the conjugate. That way you're multiplying and dividing by 1, you're not changing the value. What I don't want you to do, common mistake. Do not square the top and the bottom. I see students do that all the time. They see a radical, oh, let's just square it. You can't just square that. Right? Right, because if you do that, like if I have a half and I just square the top and the bottom, it now becomes a quarter. You change the value. Right, so you're actually changing the answer by squaring the top and the bottom. You can't do that. Right? But multiplying and dividing by the same thing, that's like multiplying by 1. You're not changing anything. You're just trying to rewrite it in a more convenient form. So don't just think you can square whenever. You can only square if you have an equation. You can square both sides of an equation. But if you just have one thing, you can't just decide to start squaring stuff. Okay, so don't do that. So here, what you would notice, why this actually works out, is that now, if you look at the denominator, what you realize it looks like, it's like a minus b times a plus b. Which that becomes a squared minus b squared, because that's the difference of squares formula. So that allows you to get a square in there without actually doing anything illegal. Right? So this is going to simplify so that the denominator becomes the first guy squared minus the second guy squared. And in the top, well, we can't do anything. Something like that. Now you'll have 1 minus 1. Now, Yeah,
Oh, you can cancel the X.
the x's can cancel.
I wanted to say it, but I also didn't want to get killed.
No, I'll only kill you for division by 0. Everything else is fine. Like, don't be afraid to say anything. It's just like the only thing that you're not allowed to say, do we divide by 0 now? Like, that's the only thing.
Okay.
Like, anything else is fine. Like, so don't be afraid. Just say what you think.
I'm blowing the land more.
Because if you have some sort of mistaken notion in your head, I do want to actually point it out so you don't make that mistake on a test, right? So definitely tell me what you want to say. Even if it's wrong, I don't care. I just want to make sure that we're all actually on the same page and you actually know what I think you know. So, but yeah, you can cancel the x's there because it's not a cross sum, there's a multiplication. And now you'll realize that we removed the potential of division by 0 from the denominator. I can just plug in x equals 0 at this point, and I would get what?
Square root of 2.
No, I was just stupid. Surprise, surprise.
Oh, wait.
So this one isn't under the square root.
Yeah.
Square root of what plus 1?
Square root of 1 plus 1, which is? Square root of 1 is what? It's 1.
So 2.
So it's just 2. So it's 2/3.
Okay, there's all math.
That reminds me of a joke. I forgot if it was a true story. It didn't happen to me. But you know those calculators, the really old ones where you enter the thing and then when you press plus it disappears and then you put in the other number, you press equals and then the answer appears. So there was a student who was like, he in the thingy at square root of 1, he was like, he puts 1, he presses the square root button and then 1 pops up. Professor, it's a calculator.
Yeah.
Square root of 1.
Okay.
Yeah, square root of 1 is 1. So that just becomes 2/3. Let's move on to square root of 0. I don't know what's happening.
I think it's closer.
If you look where it is.
Limit as x approaches infinity plus x. Square root plus 5x plus radical t. Okay, any guesses for this one?
It honestly just stresses
Is
me
it just
out.
0?
The pie?
Huh?
Is it just 0?
It'll be 0. Why?
Because the denominator is a bigger polynomial on the top,
Yeah.
so the bottom grows
So-
faster.
You look at the highest power on the top and bottom, and you notice that the highest one is on the bottom. So, yeah, this is 0. And you can say why is it 0? Because it's bottom heavy. Because, of course, step 1 doesn't work because you can't plug in infinity, it's not a number. Which automatically means step 2 won't work because you can't plug in infinity, it's not a number.
Why not?
You can't even really simplify that. Draw the graph, forget about it. Table of
Forget about
values,
it.
forget about it. Like, I'm not going to do that. Like, why would I do a table of values with this? I don't.
I think that.
We're not allowed to use a calculator, right? But it turns out you can actually just notice the highest powers, and that actually works. Now, why that works? Now, by the way, for me in this class, that's good enough. Like, you write that, you solve the problem. That's fully showing your work as far as I'm concerned. But just to explain why this happens, because there are people who don't like that, and so if you're talking to someone else and they force you to explain, the trick, quote unquote, is to divide top and bottom by the highest x power in the denominator. Always the denominator. So what happens is, this will happen. So let's say I do that here. This will give the limit as x approaches infinity of highest power on the bottom is x to the fifth, so I'm just going to divide top and bottom by x to the fifth. You'll realize that that simplifies into 4 over x to the fifth plus 1 over x to the fourth minus 1 over x squared over 2 minus 3 over x cubed plus I over x to the fourth plus bracket 2 over x to the fifth. Now what you notice is in these guys here, the numerators are constants, they're not moving, they're not going anywhere, but the denominator is going off to infinity. So those guys taper off like this. You know, the graphs of those all approach 0 as you go off to infinity. All of these guys here just go off to 0. And you would pretty much end up with 0 over 2, which is 0. So that's the long way to do that, but you just telling me it's 0 because it's bottom heavy, because you notice the top power is smaller than the bottom power is smaller. Yeah.
Does that rule only apply when you have the limit to infinity?
Yes. That's actually an important piece of the puzzle. Yeah, you can only do that. Because then these wouldn't go to 0 if it wasn't go to infinity, right? These would go to 0. Now, what about the second one? Yeah?
Is that one top heavy? Can you say that?
It's top heavy. Okay, so knowing that it's top heavy, you identify the highest powers and the bigger one is on top. What does that actually tell you? What do you think the answer is?
A negative infinity?
It is negative infinity. And because it's top heavy. For the top heavy one, you kind of have to be careful with the signs, but again, that's a fully fledged out answer. Let me just explain why. You can do the same trick. You can take the limit as x approaches negative infinity of 4 over x cubed minus 6x to the fifth over x cubed over 7 over x cubed plus 2x cubed over x cubed. So this will give us 4 over x cubed minus 6x squared over 7 over x cubed plus 2. Now these two here will go off to 0, which means the only guys in play is this negative 6x squared and the positive 2. So now, to make sure that you have this sign correct, because that's going to be an issue with the top heavy guys, it's going off to infinity, but you don't know which one, plus or minus. So what you want to do is you want to make sure that you're watching the signs. So x is going to negative infinity, so x is a really big negative number. If I plug it in here and I square it, now it's a really big positive number. Then I multiply by a negative 6. Now it's a really big negative number. Then I divide it by 2. It's still a really big negative number. So it's negative because of the sign here. Right? So you have to be careful with the signs here, but yeah, that's top heavy. It's definitely going off to infinity. It's going to be plus or minus. To know which one, just look at the signs. So we have a negative 6 times a negative, because this is x to the fifth, so that's positive on top. And then x cubed would make it a negative. So positive divided by negative, look at it even at the beginning, you'll see that you'll get a negative sign. But yeah, that's the same one. You can't plug in, can't simplify forget about the graph or plug in that a table of values. I mean, what would a table of values be for this anyway? Negative infinity? What number would you plug in? Yeah, this is almost like a negative infinity. I'm inching close to negative infinity. There are no such values. You can't do that. Right? So this trick though can get us there. Limit as x approaches infinity of 17x cubed plus 3x squared equals 1 over 5 minus x minus 2x cubed. Okay, what do you think is going to happen to this one?
Not really.
Yeah.
Since the powers are the same, don't you use the coefficient of the, yeah,
That would make the answer what?
17 over negative 2?
Minus 17 over 2.
Go.
There's our experts. This is called the ratio of leading coefficients. And you can do the same y if you want. All right, so this is, if I divide the top and bottom by x cubed, I would get a 17 here. I would get a 3 over x plus a 1 over x cubed. 5 over x cubed minus 1 over x squared minus 2 if I divide top and bottom by x cubed. That would be the result. And these guys would all go off to 0. And you're left over with the 17 and the minus 2. Now, of course, the leading term in a polynomial is the guy that has the highest power. The leading coefficient is the coefficient of that guy. So this is called, 17 is the leading coefficient in the top, minus 2 is the leading coefficient in the bottom, and the answer is just the ratio, and it's the ratio of leading coefficients, because math people aren't very creative in naming them. But that, believe it or not, you guys kind of seem to already have it internalized, but that, believe it or not, is our first special technique. And for this class, we're going to do like 2 of them, even though there are really like 4 or 5 special ones in Calc 1. But. So it says the following. If P, S, and Q of X are polynomials, then it turns out those last 3 examples actually give you all possible cases that can result from you actually taking a limit that looks like this. And I want you to notice it's limit at infinity. So it matters that you're at infinity. If you're going to limit it as x approaches 5, this doesn't apply. Right? Turns out that there are only 3 possible ways for something like that to turn out. One possibility is that you will get the answer 0. 0 will occur if you have, if the degree of P is smaller than the degree of Q. Now the degree is just the power, the highest power, right? So here the degree of the P is 3. That's the highest power. Okay. So if the degree of P, if the highest power on the top is smaller than the highest power on the bottom, it goes to 0. You call this bottom heavy. Another possibility is that you will get plus or minus infinity as the answer. This occurs if the highest power in the top is larger than the highest power in the bottom. Right? This is called top heavy. And this one has a little caveat here. Of course, you have to watch the signs. Right. Right, so you have to kind of pay attention to, okay, you're divided by a negative, and negative divided by a negative is a positive, all that stuff. So by watching the signs, you'll know whether you need to choose the plus or the minus. But it's going to be some sort of infinity. You just have to watch the signs to know is it positive or negative infinity. And finally, the last case is going to be, it's going to be the leading coefficient of p divided by the leading coefficient q. This occurs if the degree of the top, the degree of p, is equal to the degree of the bottom. The highest power in the top and the bottom are actually the same. And we can refer to this as the ratio of leading coefficients. Why does no one say bless you when you cough, but they say it when you sneeze? I don't know about that. Like, what's with sneezing? Like, you can be like, "Ah!" You can be coughing up blood, no one's gonna say bless you. But you go like, bless you, everybody bless you. So that's our special technique of the day. So, highest power on the bottom, it goes to 0, it's bottom heavy. Highest power on the top, it will go to plus or minus infinity, that's top heavy. And if the highest power on the top and the bottom are the same, it will go to the leading coefficient. So here, you can immediately know that this will go to 0 because that's next to the fifth and that's next to the cube. You'll know that this will go off to some sort of infinity because that's next to the fifth, that's next to the third. And I just pay attention, okay, I'm putting in a negative infinity and I read to the fifth power, so it's negative. But you have to pay attention to what the signs will be. Here, the highest power in the top and the bottom is a cube, so it just goes to the leading coefficients, the ratio of those leading coefficients. So you can just look at these, like the last three. If I give you problems like that, you should just be able to look at them and tell the answer. And as far as showing your work goes, you can just write down these phrases. So the answer is 0 because it's bottom heavy. But I'm fine with you writing that down. You don't have to actually show this. Yeah, and we'll stop there. I also, currently we're about to diverge, but currently we're doing the same thing that the big boy top one is doing. And you guys actually did better than they did, so pat yourselves on the back. They didn't remember about conjugates or any of that stuff. I'm like, guys, remember the conjugate? Like no.
You know what? Yeah. My friends.
So yeah, so I'll see you guys. So on Tuesday, the quiz is on limits, of course, so practice this stuff. Did you do logarithms this week? I do know. No, it's only limits this week. So quiz on Tuesday is what we did this week, so limits. You know how to compute them, you know how to look at pictures and talk about limits, etc.